Okay, good afternoon. I'm here to introduce Dr. Robert Saylor, our speaker this afternoon. And Dr. Saylor's had a 40-year career at the University of California at Berkeley as a professor in mechanical engineering. His teaching and research interests included rocket propulsion, energy, conservation, combustion, air pollution, and regulatory policy. In that capacity, he's the author of, or co-author of, 350 technical publications and books. He chaired the Energy and Resources Group while he was there, and he was the first class of 1935 professor of energy. In January of 2006, as you know, Governor Schwarzenegger appointed Dr. Saylor to head the California Air Resources Board. And he brings back his experience serving as a board member back in the 1970s. Today, Dr. Saylor will talk to us about from science to regulation, his experiences and perspective on his 10 months on the job training. With that, Dr. Robert Saylor.
Thank you, Richard. An introduction which includes my endowed chair professorship at Berkeley always causes a lot of confusion, especially in Japan. I can see people when they introduce 1935. Well, he's pretty old, but he doesn't look quite that old. That, of course, is the graduating class of 1935 who came up with the funds. And I must say that that association with this group of people who are now nonagenarians, I guess, it's just been delightful. They're an energetic group of people involved in everything, especially affairs at Berkeley and big Cal boosters. For those of you who haven't noticed, for the first time in 40 years that I've been at Berkeley, Cal has a team which has an honest chance of going to the Rose Bowl this year. I hate to say that because I'm sure they'll lose the next 4 games and that'll be the end of that, but it's an exciting time. Well, I certainly appreciate the opportunity to talk to you about my experiences here and my perspective on how science and regulation come together. And I appreciate all of you coming. I have a feeling that those of you who work for me may have felt obligated to come, but hopefully it's out of curiosity rather than obligation that you're here. What I propose to do is to look at 4 areas which have an important science and regulatory dimension to them. This has to do with the vehicle problem, vehicle exhaust and photochemical smog, of particles and health, of oxides of nitrogen, which happen to be dear to me and for personal reasons, which I'll tell you about, and of course global warming. And then I'd like to go through a whole list of things which have been very interesting challenges while I've been here, and some remain challenges, and successes are the ones that you did a great job on before I got here and solved the problem. And I would like to just run through a whole list of those towards the end. Okay, the 4 regulatory issues. You might ask, what does this picture have to do with regulation and science? The answer is nothing. What it does have to do with is that there are some scattered pictures in here from my John Muir Trail trip, the most recent one. And I'll be glad to, at a drop of a hat, give a seminar on 23 days on the John Muir Trail if you'd like in the future. First of all, the issue of vehicle exhaust, atmospheric chemistry, and smog. And that's really where the birth of the California Air Resources Board came from, was this whole issue. The problem predated just about everybody in the room here, I think, with the exception of perhaps myself. I'm old enough so that I can remember going to Los Angeles in the 1940s and in the 1950s, and the smog condition there was truly abysmal. It was not just a matter of visibility, but you could smell the air, and especially the eye-smarting agents in the smog were just awful. I can remember when I got to be old enough to drive in the 50s, that I'd go down there, you'd really have to pull over to the edge of the road because your eyes would water so much. Well, the air pollution control started with the local districts, and I would call your attention to the fact that in the 40s there were 2.8 million vehicles in the whole state of California. The tie between the smog problem and automobiles was not so obvious to anybody. The people in Los Angeles assumed that it was the result of the petrochemical industry that had built up during the Second World War, and in particular butadiene, a big butadiene plant that was the heart of a synthetic rubber industry that there was there. And it took another university professor, who also turned out to be the first chair of the Air Resources Board, and the last time they went to a university professor to chair the Air Resources Board, to draw the, I hope that isn't mine, which maybe reminds me that I should do something about it because it's bound to go off, I think. Yeah, let me make certain I turn that off. Wow. Professor Hagen Schmidt was a odor and taste chemist at Caltech, sort of somebody unlikely to get into the area of atmospheric chemistry. And he really nailed it when he drew the connection between hydrocarbons and NOx and the formation of what was then thought of as photochemical oxidants, really a whole mixture of oxidizing compounds. Now we tend to focus on ozone. Then it was really more than just ozone. And in addition to that, he suggested that he knew where they were coming from, and that was from the automotive fleet in the LA basin. Well, as you can imagine, this was not very popular on the part of Detroit. First of all, to suggest there was a problem, second, that they had something to do with it. But we've seen that same sort of pattern when new problems are identified and when their evidence mounts about where it's coming from, that the sources tend to deny that they're part of the problem, and the next thing that happens is that they say, well, maybe we're part of the problem, but there's nothing we can do about it, and then eventually, through regulatory processes, they tend to address the problem and really show that they do have the ability to solve the problem. In the 60s, the Motor Vehicle Pollution Control Board was formed, the predecessor to our Air Resources Board, and regulations started coming in. The first was the positive crankcase ventilation control. California then, before the Clean Air Act, was given authority to set its own motor vehicle emission standards by the federal government, and that was made formal in 1970. And we established tailpipe standards for CO and hydrocarbons. The Air Resources Board was formed, and Arie Haagen-Smit was named chair of the board. So a lot happened during the 1960s. The big event of the 1970s was the U.S. Clean Air Act, and that's a wonderful piece of legislation which has really sustained air quality control in the United States ever since then, and has undergone very little change during that period of time, I think, because everybody recognizes it's a fine piece of legislation. It would not be a good idea to weaken it. Ozone was hitting almost 0.6 parts per million in Los Angeles during that period of time. We think, actually, you have to sort of guess about what the measurements were because it wasn't measured as ozone during that period of time. But that's probably about what it was. California put in place the oxides of nitrogen standards, and again, this was a very difficult thing to get in place because the auto industry, now believing in photochemistry and the atmospheric chemistry of hydrocarbons and NOx, pointed out that NOx really scavenged ozone, and that if you wanted to solve the ozone problem, what you need to do is put more NOx in the air and not less. And of course, with all things like this, there was some truth to it, so it was a bit difficult to get through this argument, and in fact, in some ways, we're still dealing with it, although I think our ability to sort out what is NOx controlled and what's not NOx controlled is much better now than it was then. The system of ambient air quality standards, the national ambient air quality standards came in place, and that's of course what really drives much of what is done in California. That forces our state implementation plan program, and that what puts the weight of law behind much of what we do. The auto industry came up with a solution which was originally thought to be absolutely impossible. That is, that instead of modifying the combustion process to clean up the engines, that you would sort of let that go a little bit and clean up the exhaust, process the exhaust. It was suggested this was like putting a chemical processing plant on every automobile, which of course in a sense it was, but what people did not realize is it could be done very efficiently and cost effectively and small enough to get on an automobile and reliable enough to last in excess of 100,000 miles. Great success story. The problem, of course, is the figure in the lower right-hand corner, that the number of automobiles had crept up in this 30-year period to 12 million vehicles. And this, of course, continues to be the big problem in California. The 80s was a period of consolidation of the rules and addition of other things, more stringent standards, the beginning of the ZEV program. California's pioneering work on onboard diagnostics as an approach to ensure the durability of the vehicles, which was and remains a major problem. And in addition to the criteria pollutants, the toxic air contaminants began to become regulated. Well, everybody in the room, or practically everybody, was probably here in the 1990s, so this is history which you have lived. Very important, I think, during this period of time was the reformulated motor fuels, the reformulated gasoline, the reformulated diesel, because that tackled a whole nother side of the problem, how to assure that the fuels were doing their part of the job, and we're continuing to work in that area. Smog Check was expanded and made more stringent, and the LEV 2 standards were put in place, and really these are in the 98-99% reduction from uncontrolled vehicles. And if every vehicle on the road indeed had that level of emissions, the motor vehicle problem would be solved. We aren't quite there yet, and ensuring that these vehicles do that over their lifetime, I think, is our #1 challenge in the motor vehicle area. And then there were some hiccups. You know, we allowed or encouraged the introduction of MTBE, and it turned out that was not such a great idea from the standpoint of water quality, and then it had to come out again. Well, I think that's, again, a case where science showed that there was a problem, and we were willing to deal with it, even though it was a difficult thing to do, an embarrassing thing to do, actually, because we were nailed with being responsible for it being there, which was not quite true. It was really the choice of the oil companies to go that route. And we've learned since that they knew that there was a water problem when that happened, so it's unfortunate it happened. And then we're into the present decade. And perhaps and I'll come back to this, that there were no smog stage 1 alerts in the LA basin starting about this period of time. And then we saw some really landmark legislation which has occurred very recently. First of all, AB 1493, the Pavley Bill, just an extremely important piece of legislation in reducing greenhouse gas emissions for motor vehicles. If there was any one thing which made me accept this appointment, it was that piece of legislation and the thought that I could be part of putting that in place. I probably should have gone back to law school before I took that on, but I still have a gut feeling that these are problems which the engineers can solve with pretty straightforward ways, and they ought to be given the authority by the industry to do it. And then, of course, this year we have AB 32, the California Global Warming Solutions Act, and I didn't dream last January that this was on the horizon, that this would be happening, and that the California Air Resources Board would be given the responsibility for making it work. Bottom line, 26 million vehicles and growing in California. Okay, the next issue I'd like to discuss, does anybody know where this picture is? Well, we're going to have a quiz at the end on all the things. And it's a place called the Big Horn Plateau. It's down in the southern Sierra Nevada. Now, a lot is changing in the health effects area and the understanding of what it is about particles that is toxic. For a long period of time, people assumed that air pollution would be experienced in terms of pulmonary effects. I mean, we breathe the air, and the air affects the lungs, and we know that it's an irritant and induces asthma and all things which are related with lung effects. But then the evidence began to mount, almost 15 years ago, that something else was going on, that there were associated cardiovascular effects, especially heart arrhythmias, which seem to be correlated with particulate air pollution. And I remember that first evidence was becoming apparent. Actually, it was a result of some animal studies, work being done at Harvard on dogs. I was part of the health effects research committee team at that time, and I actually voted against giving Harvard money to do experiments on dogs because I thought it was so unlikely that they'd ever see anything that it wasn't fair what they were going to be doing to the dogs as a process of it. And I'm sorry I was wrong, but I was outvoted, and that work was funded. And indeed, they showed that when the dogs were exposed to ambient particulates, that arrhythmias were introduced. And then people began to look at other places for evidence of this sort. And the epidemiology became stronger and stronger, partly because the science of how the mathematics of epidemiology evolved during this period of time. I can remember not too long ago, 20 years in my time scale, at Berkeley talking to one of the epidemiologists there. I don't think I'll mention his name because it might embarrass him that he said this, but I think he was absolutely right. He said, don't worry about a relative risk that's greater than that's less than 1.5, it's meaningless. And I sort of took that to heart, and he meant it was sort of meaningless because the uncertainty in being able to establish that level was not very good. Not that it was necessarily meaningless in terms of health effects, because a 50% increase in something is a pretty substantial health effects, especially if it's mortality. But of course, the databases, the amount of information was available, especially from these large studies, the National Cancer Institute study, gave a lot of strength to the epidemiology, and suddenly it began to show up that the relative risks at 1.1 in that area for mortality associated with particulates was real. And it's the epidemiology that's been driving the air quality standards more recently, rather than the toxicology. So that's a complete change. I don't know if I have the time period right, but I think at least in the last 10, 20 years that's happened. This also means that if you're going to get the epidemiology right, you better get the exposures right. And this is where we are now that understanding the exposures is really difficult to do because it tends to be based upon a few monitors averaged over large areas, and how you really do that. And what if the whole effect is somebody driving on the freeway, which is only a small portion of their day, and you're trying to relate their exposure to where they live or where they work? How do you sort that out? Well, I believe that we're funding research and other people are trying to tackle these problems, but doing the best we can, the strength just gets stronger and stronger between particles, especially small particles, and mortality. Well, there are a lot of other issues. What is the mechanism? What is the size effect really? Are the nanoparticles really a big part of the problem? Certainly the composition has something to do with it. These are biochemical effects that must be causing this, but we really don't know any of that yet. So what do we do about regulation? Well, we know enough, so we move ahead, and it has to be the right thing to reduce the mass of the particles, and we're reducing the mass. We're keeping a careful eye on the numbers to make certain as we reduce the mass that the numbers don't go up. There was some evidence that some technology allowed that to happen. So it's an area in which the science is certainly incomplete. We need more to decide what to do next, whether to have a number standard or not, whether nanotoxicity is a big issue or not a big issue. And OEHA and we and others are going to be focusing a lot of attention on trying to come up with these answers. Just to emphasize the exposure issue, I think that those of you who have been following this area, it's the Jarrett study, which came out about a year ago, that has really caught our attention, in which he broke down the exposure to a more localized geographic area, and in doing that showed that the association between particles and the number of health end effects was strengthened by doing that. And notice that these are relative risks that are less than 1.5, going back to my original observation that was not considered something you wanted to worry about too long ago. Certainly strong. The general association with atmospheric particles and lung cancer is a very interesting one, because we've always focused on diesel particulate as being the lung cancer link. You know, it may be, maybe it's the diesel in the general ambient particles that is the causative agent, but there may be something else going on there. And then there's the issue of the ultrafine particles and their association with freeways, and how it's a bad idea to live next to a freeway or to put schools next to a freeway. And that has led to regulatory and advisory action by the Air Resources Board. I think exactly the right thing to be doing. Okay. Third science issue, oxides of nitrogen. Why is this special to me? Well, it's because oxides of nitrogen are formed primarily in combustion processes, and that's my field, is combustion chemistry and the formation of things like oxides of nitrogen. But it really goes back to that. And when I speak of oxides of nitrogen, I'm really talking about a whole family of compounds. NO is the one that's formed in combustion processes. The oxides of nitrogen coming from combustion process, about 90% NO, maybe 95%. It depends on a lot of different things. The understanding of its chemistry is well established now. Those pair of reactions are the ones that control nitric oxide in combustion processes. They were proposed in the early 1940s by the Russian chemical kineticist Zeldovich, and they're called the Zeldovich mechanism. See, I can't resist putting a little bit of academic stuff in this, so that but you can always pass that on, you know, and sound erudite. The second reaction occurs almost immediately after the first reaction. It's the first one which controls the process. So what you have to do is have oxygen atoms. You get oxygen atoms by having excess oxygen and high temperatures. So that's why it happens in combustion processes. The second oxide of nitrogen of interest is NO2. And this is a little more complex in how it forms, but it really is the transformation of NO to NO2 in the post-combustion process where you have an excess of OH radicals and things are cooling down. So this is like in the exhaust of a diesel engine, or the exhaust maybe outside of the engine in a jet engine. One of the interesting problems I worked on was the formation of NO2 in scramjet combustors. You know what a scramjet is? It's a supersonic combustion ramjet which NASA has been testing off the coast of California recently successfully. Mach 6 and above, they worked very well there. And they form huge amounts of oxides of nitrogen. It's hydrogen and excess air, high temperature combustion, very high temperature combustion. And they also form a lot of NO2. In fact, one of the companies that was big on the development of this is Marquardt Corporation in the San Fernando Valley, and they had a test facility there. And they were reduced to testing at nighttime because the plume of brown gas coming out of their stack when they were testing was so great that they got a lot of complaints. It was long enough ago, so I'm sure the statute of limitations have run out on that. In combustion processes, the first reaction is the one that forms NO2, and in the atmosphere, it's the second one, which is important. That is, the NO scavenges ozone and forms NO2 in the process. That's part of the photochemical cycle. But also, more recently, we've learned that NO2 is formed in catalytic converters, especially the catalytic traps that are on diesel engines. And this may or may not be a problem. Probably not a problem in California because we don't have that many diesel vehicles on our streets with traps on them. But it's something we recognize and we're keeping an eye on, and have put a limit on the amount of NO2 which can be increased by these. There's a dimer of NO2 also, N2O4, which is called nitrogen tetroxide. It's a rocket propellant, and that's how I first got interested in this. I did my thesis on the chemistry of nitrogen tetroxide and hydrazine, a lot of nitrogen chemistry. So it was sort of natural to make that transition into air pollution chemistry. N2O, nitrous oxide, turns out to be a very important compound because it's a very potent greenhouse gas. And its source is primarily from the soil, from biological processes in the soil, and it increases as the amount of fertilizer increases. So So you have a heavily fertilized crop such as grain, corn, it generates N2O. So while you're saving on greenhouse gases because it's a renewable fuel, it's also contributing to greenhouse gas. So there are a lot of complexities, science complexities to this. And this is an issue which we're going to have to be dealing with now that we're responsible for the inventory of greenhouse gases, on how we account for all these things and get the accounting right. N2O is also formed in the upper atmosphere as well. And on automotive catalysts, when they operate rich, you also get N2O out in there. So a lot of different places it comes from. The next one is nitrous acid. And that's primarily a tropospheric component associated with photochemical smog. It builds up during the night, and when the sun comes up, it photolyzes immediately and sets off the reactions in the morning. But it's also formed in combustion processes. Generally missed that that's the case, but if you look for it carefully, you'll even find it in some of the tunnel studies that nitrous oxide is there. Nitric acid, of course, and on it goes. All the nitrates are part of this. So that's your lesson in nitrogen chemistry. Well, there's a big issue right now, and I noticed that we have an OEHA representation here as well, and that is what the air quality standard for NO2 should be. And it's being reviewed at the present time, and it'll probably be tightened. It looks like the evidence is that our current standard is not sufficiently protective. We have a standard of 250 parts per billion for 1 hour. WHO has just announced their recommended worldwide standard is 100 parts per billion, which is a lot lower than what we have. I don't think the evidence is there to support the number which they have come out with, but that's something that will be considered in next year, I think. The NO2 standard will be considered. And the issue that we must face is the formation that occurs on catalytic traps on diesels. And this is being driven home by what occurred in London. And again, this gets a little bit personal because this monitoring station on Marylebone Road was about 2 blocks from where I lived for 2 years. I used to go down there and take a look at it, and I thought, wow, that's very close. And get on the website and you can see what you're breathing. Well, something very interesting happened about 2003, and that is that the amount of NO2 which they're picking up increased dramatically. This particular metric is tends to exaggerate the effect a little bit. This is the number of hours over the 200 micrograms per cubic meter NO2 level, which is their air quality standard. And that went shooting up, and this is very closely associated with the introduction of catalytic traps on diesels, primarily on the buses, but also on the taxi cab fleet. The British their approach is to put NOx control as a retrofit on the buses, and they've started a program to do that, which is an expensive way to go about doing it, but this is being started at the present time in London to address this problem. Okay, number 4, global warming. I cannot think of an example in which the science and its development has been more dramatic in forcing, finally, regulatory action. I can recall first seeing this problem speculated upon in the 1970s. And I can recall giving a talk at a international meeting of combustion scientists in which I tried to point out problems of the future, and one of them I said, if it turns out that CO2 is indeed a problem, the combustion community had better rethink, what it's going to spend its time doing. And I was absolutely practically booed out of the room. And some of the in fact, one senior scientist came up to me, a professor at MIT, and said, Bob, that was absolutely irresponsible for you to even suggest that there might be a problem. Well, it's 30 years ago, and I don't think that even he, if he were alive, would question the science which is behind this now. So nobody recognizes my landmark on these pictures. Wanda Lake, just below Muir Pass. Now, I was asked at the meeting early this week, what really convinced me that this was a problem. Well, there's an awful lot of evidence. I tend to be convinced by the models, which explain what's going on and come up with the right numbers. But that's pretty abstract, I think, for most of the public to go along with something like that, and maybe even for you. But I think perhaps most impressive is just what's happening to the temperature. It's going up, and it's going up very rapidly, and it's going up at a time when the greenhouse gases are going up. So there's a coincidence there, and it's during our lifetimes that this is happening. It's during the last half of the last century that these things really became pretty evident, that it wasn't just an oscillation or a natural variation that it was occurring, but that it was really happening. The measurements are getting a lot better. The red on this figure are things that are actually measured, that is quote-unquote thermometers, but not quite thermometers the way you think about them. And the other part is from all sorts of other information, tree rings and glacial deposits and isotope ratios and all sorts of things like that. But they overlap. You get the same thing. So if we'd had thermometers 1,000 years ago, pretty good evidence that the red line would go all the way back across this figure. The big uncertainty in global warming is what's going to happen. What the effect is going to be, how serious it's going to be, how fast it's going to be. Is the thawing of the tundra going to release lots of methane, which is going to drive things up much faster than we think? Are the methane hydrates in the ocean going to be released? Is any one of these catastrophic events going to happen? Or is it going to be a much slower process and things are just going to warm up gradually? Well, we don't know, but I think that the likelihood of something really bad happening is great enough that we cannot, in good conscience, not act at the present time. And the good news on all this is that the action we would take would be a good thing to do anyway. It would save energy and save money and reduce the dependence upon petroleum and have a lot of other good benefits as well. Now, what gets the public's attention is not the scientific data so much, but pictures. The picture on the left there is a shot, I think, well, it was a 2003, and I suspect during the middle of the summer, of the ice cover, the Arctic ice cover. And the red is what the level was from 1979. Well, I was a little bit suspicious when I saw these pictures. I pulled up the NASA database, which is wonderful that you can get all these things. And they have every year, so you can follow every year. And sure enough, there are oscillations. Some years are worse than others. But there's no question that this trend is occurring. And they did, of course, what you'd want them to do. They calculated the surface area and did a regression on it, and there's no question that it's happening, and it's substantial. So it seems likely in our lifetimes that the Northwest Passage will open. There'll be shipping going through this area. I don't know whether that's good or bad. It's good for the shippers, I suppose. It might not be that great for the environment. But again, the public can see pictures like that, but they can also see, I think it's the polar bears. That I have a good friend who has a father who is about as conservative and skeptical as you could find. But the polar bears got his attention. He said, better do something about this. Well, whatever it takes. And I think so. I think these kind of pictures and of glaciers melting, that's what's really gotten the attention of the public. And maybe the politicians as well. Maybe that's the kind of evidence that really appeals to them. But it's our responsibility to look at the science, and if we think it's convincing, to tell people why it's convincing, simplify the science so that people can understand what it means. So the science is there, and it's certainly driving what is going on. Politically in California, the governor came to his conclusion before I arrived, and I thought, boy, that's about right. That's somebody that I would be happy to work for. And I said that before I was asked to work for him, but so it all turned out very well. And now a whole series of things have been happening, and it's not just AB 32. This was all in place, and the Climate Action Team report really lays out just about everything that is understood and what needs to be done as well. So while we're moving ahead, it's not bad to go back to this report that's almost a year old now and see what's in there. It establishes the importance of a mandatory greenhouse gas registry. AB 32 puts that in law. It suggests a cap and trade system. AB 32 allows that to happen, doesn't mandate it, but says that this is something that we can consider, and we will consider it. It suggests that alternative transportation fuels are going to play a role in this, and so on. The Pavley Bill, which has been in place for over a year now, also lays out all sorts of things and goals which are very consistent with AB 32 and very important to AB 32 because they're an important part of the greenhouse gas reductions which we will need to be obtaining. One of the interesting things in there is that it has to be cost effective to the consumer. Well, I mean, what more could you ask for? Here you pay for technology that's going to pay back during the time that you own the vehicle. It sounds like a freebie to me. It sounds, sort of a no-brainer that that's something you want to do. In the long term, if we're really going to think of 2050 and what needs to be done there, then we're going to have to go further, of course, than what Pavley calls for. But this is plenty for us to bite into over the next 10 years. The nice thing about the Clean Air Act is not only does it give California the right to set its own motor vehicle emission standards, but it also gives other states the right to join us. And more states are doing so. Right now, there are 10 states that are going down the same route we are. They represent about a third of the sales in the United States. And that's about, if we can make this stick, about the tipping point. The automobile industry will say, well, a third of the vehicles we sell, we might as well make them all the same. There's no reason to make 2/3 not as clean and a third cleaner. So it's very important that we have those other states with us and that they stick with us and that we win this lawsuit. The lawsuit requires that we cut down on the CO2 emissions, basically, and other Kyoto greenhouse gases from motor vehicles. Really, it isn't all that demanding what is required there. China has just put in a regulation on CO2 emissions from motor vehicles, which is more stringent than ours, which is encouraging that they've done that. So it looks like the whole world can head at least as far as what we're proposing under the Pavley legislation. And there are a lot of really important things in AB 32, the California Global Warming Solutions Act. First of all, it codifies what our goals are to be. That is to get back to 1990 by 2020. I mean, that's pretty straightforward on what's expected of us. It applies to the Kyoto pollutants, and here's an issue in which the science really has to step up and tell us whether that's sufficient or whether we really do need to be worrying about more than the Kyoto pollutants. There's a lot of concern about black carbon, for example, and its role. Whether the Kyoto 100-year time scale is the right one, or whether we should make certain that we deal with the shorter lifetime species and give them a higher weight. We're given the responsibility for implementing most of the measures, making sure that they happen. There are other state agencies that are going to play a very important role in this also, notably the Energy Commission, the California Public Utilities Commission, the Integrated Waste Management Board, and on. Really just about every state agency has something to do with a sector that's involved in greenhouse gases. Natural resources and forestry is another example of that. And the bill also lays out a schedule in which we should be doing this, and we don't have much time to think about it. I mean, January 1st, we take over the registry, and we must come up with a substantial plan by July, the end of June next year, and so on. So there's going to be lots to be done and a reasonable but rapid time scale. What we want to do is to put us on the trajectory of the bottom there, CO2, equivalent emissions. The green line is what happens if we do nothing, business as usual. And the purple line is what we have in place already if we can make it happen. So we're not halfway to where we need to be, but we're on the right direction. Okay. I don't know whether I should give you a little more touristic interpretation. This is Painted Lady, Ray Lakes, Southern Sierra Nevada again. I just, I'm building up for the next seminar, which I want to give on the Sierra Nevada. Blatant advertising. Okay, some successes and challenges in what you've been doing and what we need to do. And this is just a list. Meeting air quality standards. Really done a good job. Lead, gone, solved. And it's not only solved, it's down a factor of 10 beyond what the air quality standards required. One of the most important things done early in the program was getting the lead out of gasoline. Think of what happened worldwide. Lead is out of gasoline essentially everywhere in the world today. So what we started, 1975, I think about then, 30 years ago, has spread worldwide, 30 years. Amazing. The same sort of thing is going to have to happen with the global warming gases. I mean, if we reduce our emissions by 100%, it's not going to make any difference at all. We're going to have all the global warming problems. So we have to adopt things that will spread worldwide. The nitrogen dioxide standard is met everywhere. Sulfur dioxide is met everywhere in California. Carbon monoxide has finally been met everywhere in California if we're sort of ignore Calexico, I think, and what's coming across the border, which is amazing. I didn't think that we would ever get that hot spot in Los Angeles killed off, but it's just from the automotive fleet, but getting cleaner and cleaner. So we're left with ozone and particulate matter, big problems. We were headed toward it, but while we weren't watching, the understanding of the effects got better and the air quality standards got more stringent. So that's going to cost us some time in doing that, and I don't think it's unreasonable that if we have raised the bar on what we want to do, that it's going to take us a little bit more time to get there. Definitely headed in the right direction. The worst area has been the South Coast, and they're doing very well. It's coming down. A little bit of worry of what's been happening in the last few years. It hasn't been coming down as much as it should have been coming down. The South Coast is, concerned about it and what's causing it, whether it has to do with the photochemical reactivity of the hydrocarbon mix that's in the basin. They think that may have something to do with it. Well, again, that's another science problem, which we've got to figure out whether they're correct or not. Or they actually aren't saying that. They're speculating that might be one of the reasons it's not coming down as fast as they would like for it to. The big problem in California is growth. And I think you can just say growth, growth, growth. That's what we're facing, and it's going to continue. It's too nice a place to live, and we're going to continue growing. The population is going to go up, and the VMT is going to go up, and the VMT historically has gone up faster than the population, and we've got to reverse that. That has to become part of the strategy. That is how to reduce the VMT per person in the state of California and increase the quality of life. Well, I can tell you my quality of life is greatly improved by taking the train between the Bay Area and up here. Driving in the traffic between those two places is not all that much fun. The train is very good, and we've got to convince people there are other ways to do that. I live close enough to hear that I walk to work in the morning. What a wonderful idea to live someplace where you can walk to work or bike to work. But we've got to look at the growth. We sort of pat ourselves on the back on how well we're doing because the emission standards are getting tighter and tighter. But everything we must multiply by the growth, the number of people, the vehicle miles traveled in our projections. And that makes things harder and harder to do. In energy efficiency in California, while the rest of the country has been consuming more electrical energy per capita, we've been dropping a little bit. That's great, but on the other hand, the population's been going up a lot, so the amount of electricity we're consuming is going up. We mustn't forget that. It's too easy, as the Bush administration says. We are reducing energy intensity in the United States. Duh. We're reducing it because the gross national product is going up, and if you divide the energy consumption by the gross national product and it's going up, the ratio goes down. You know, we're moving from an industrial, heavy industry economy to a service economy, an information economy. That's, of course it's going to go down. And that's partly the same reason that the energy efficiency in the state of California is improving. That is, that the number of people are going up. So the amount of energy per person is going down because the population is going up. Not to say that's not a worthwhile thing to do, but don't forget the growth will erode everything we do if we don't do better. And in some cases, I think we have to begin to educate the public on what they can do to modify their lifestyles to contribute to the solution. The light-duty vehicle fleet, I think, is just amazing what's happened. And, you know, I give credit to you and to the auto industry. You know, the auto industry fought this for a long time, but they did come up with a product, very durable, very clean, and hopefully will remain so over the lifetime. That's our job now, is to keep decide what to do with the old cars. Sawyer's theorem number 3 is that all cars become high emitters before they die. And what you want to do is to design something in the car so it dies first. And there's a regulatory word for that is called scrappage, so it's a good thing to do. Well, this just emphasizes that the emissions are much higher in the old cars, and because of the population distribution, the oldest cars are not the big part of the problem, but it's that 15 to 20-year-old car right now that is the big part of the problem. It's tough to deal with those. You know, they belong to people, and you have to ask them to do something. Smog Check programs. Californians are remarkably accepting of the Smog Check program. I would have thought they would just be really upset about it, but they're really going along with it, and we've got to convince them it's worthwhile, it's good investment, it's working. Got to make it work when it doesn't work. Got to make it honest when it's not honest. Land use planning. Now, here's an area in which we have absolutely zero authority, but it's an area in which I think you've done a pretty good job in using the bully pulpit and the land use planning handbook. People really look at that, and they're beginning to take that into consideration in land use planning in California. We need to get the message out there. You know, I think people do want to do the right thing. They don't want to expose people unnecessarily to bad things. And even the land developers, you know, if we get the word out there that you really don't want to buy that brand new expensive house that's next to a freeway because it's bad for your health, the land developers will get that message pretty soon too. I'll probably get sued for saying that tomorrow. One of the challenges we face is the ZEV program, and we're going to be, you know, taking a look at the ZEV program again. There are two areas. The battery side of it remains, I think, an area which is very promising. I think there's a role for pure battery electric vehicles, not as full range, full performance SUVs, but for vehicles appropriate to certain jobs. Commuting, going to the grocery store, tasks such as that. The fuel cell vehicles, the auto industry is putting a huge amount of money and effort in developing the technology for fuel cell vehicles. I sometimes ask myself, why are they doing this? And I think they really see that as the technology of the future, and they don't want to be left behind, that they see that sometime in the future there's going to be a new way of propelling automobiles. I think it's a long time off, but I think it's well worthwhile, every effort we put into pushing that technology, that they put into developing the technology, beginning to get experience, getting hydrogen out there. The big problem with fuel cells is hydrogen and where the hydrogen is going to come from. And at the point where we have electricity which is carbon-free, which hopefully is in our future, then suddenly hydrogen makes a lot of sense because it gives you something to do with the electricity at nighttime when you have excess capacity. We'll be learning more about this area and how the technology is coming from our expert panel, which will be reporting back to us early next year. And I certainly look forward to their report. The success side of the ZEV program is that it's brought a lot of clean vehicles with longer term warranties, extremely low emissions. It's encouraged hybrids, and certainly hybrids, I think, have a major role to play. There are vehicles out there in the ZEV class that clean up the air as they drive around the streets of Los Angeles. Think about that. You know, here's a car that's taking air in, and the exhaust is cleaner than the air that's going into the car. What an amazing technology. I'm not suggesting we should have a lot of those cars driving around to clean up the air. That's not the point. The point is that it's really an amazing technological accomplishment. How do we reduce the amount of petroleum which we use? Petroleum is the fuel of transportation, and transportation really needs a high density, energy density fuel like petroleum, and will for a long time. Well, the obvious way to do it is to make the vehicles more fuel efficient. That's sort of a no-brainer that that's the way you would do it. Alternative fuels, I think, hold a promise, and they hold a sort of a double promise if they're tied into what we can do in California locally. I don't think that growing grain in Iowa and turning it into ethanol and shipping it to California is the way to do it. We know that the energy balance on that is really sort of marginal. But, you know, it looks like cellulosic ethanol may be possible, that there are large resources of cellulosic waste or crops grown for cellulose in California. Probably not enough to replace all the petroleum, but certainly enough to make an important contribution and to reduce CO2 in the process. We're going through the issue of whether it should be E10 or E85 or both, and you know, our agency can make the call on that. The number one rule is we're not going to compromise air quality. We're not going to do something which will cause tailpipe emissions to increase in doing this. You know, we have the authority to mandate vehicles that are flex-fueled vehicles that will burn E85. Or, you know, we might want to exercise that authority. But this is something we're going to be trying to sort out in the coming year. The predictive model, which really controls how much ethanol comes into the fuel and how the refiners adjust for that, is about to be revised, and everybody watch that, see how that turns out. We've set ourselves a really difficult goal to reduce diesel risk. That means diesel particulate, 85% by 2020. And that's going to require a lot of focus on how we really get that done. If we wait long enough until all the diesel engines are replaced by 2007 diesel engines, that'll sort of happen. But the fleet, there are a lot of engines in the fleet that don't turn over in 13 years, that have a much longer lifetime than that, which means we've got to work on the retrofit or the more rapid turnover of engines. But again, you know, there's a growth problem in this sector. With goods growth coming in California, I think that means more trucks. Part of our strategy, I think, should be to take the growth into the railways for goods rather than into the highway fleet. It's much more efficient to do that, and should be cleaner. It's not, because the locomotives are not very clean yet, but we in the EPA are working on that. Light-duty diesels, you're going to begin to see those sold in California again, meeting the LEV 2 standards, the really clean light-duty diesels. I think just every manufacturer in the world is planning to do that. California is a good market, and they want to bring them. These will have traps on them to meet the particulate standards and some other technology for the NOx standards. Looks like the light-duty vehicles will be using NOx adsorption technology or onboard ammonia generation and selective catalytic reduction technology. This area is moving very rapidly. Lots of different things are happening. They're going to go into larger vehicles. You know, we may not want to facilitate any larger vehicles, but if there are going to be larger vehicles out there, it's a good place to put the diesel engines because you save a lot of energy in doing that. Diesel PM reduction has been a real success story, and this predates the trap. The engine modifications that occurred over the last 20 years really reduce particulate emissions from diesels. It's pretty hard to go out there and find a smoking diesel on the road now. Even in the older transit buses, they must have all disappeared. I live in the Berkeley Hills, so I have a good place to look, and I don't see them anymore. So that evidence is really strong from tunnel tests over a period of years. And we too are supporting a whole series of tunnel tests, and I think it's very important to have this kind of data over multiple years so you can really pick up on what the trends are. The new technology, of course, is the trap, and there's lots of experience of that in Europe. It's going to work fine, and the manufacturers assure us that they're improving fuel economy when the traps come on, so it should be a win-win for everybody. The oxides of nitrogen, I'd put this in a challenge. Challenge is sort of a word for something means, well, it didn't work out all that well. This is an area in which I think it's been a failure, the heavy-duty truck NOx program. It just didn't work out the way the standards say that it should have. And as I think most of you in this room know, the industry chose to trade off fuel economy and NOx in what we thought was a devious way. We just lost our latest lawsuit in this area. So it's all pretty dismal until you get to 2010, when very stringent nationwide standards come in. I just completed a trip to the Midwest to talk to the heavy-duty engine manufacturers because, frankly, we're worried about, how the technology is coming. Are they going to do it? Is it going to work well? Is it going to be acceptable? Consistently, we heard, yeah, it's going to work. We have fleets of vehicles out there now that meet the standards. We're confident. Don't worry about it. That they're primarily going with urea-based selective catalytic reduction as the technology. This works. There's a lot of European experience on it. We're a little, we in the EPA are a little bit concerned about whether people fill up the urea tanks and what you put on in the systems to make sure that happens. But I think that can be assured. There are other approaches, though, and everybody is working on other approaches as well. And I think in the long term, they see other things. There is an incredible amount of work going on in what is known as homogeneous charge compression ignition combustion, which is a diesel combustion process which produces practically no NOx and no particulate. This is already in production, but the engines that are out there only operate over a small load range, a light load range. So it's a possibility, and they're very optimistic about it. The onboard formation of ammonia to run selective catalytic reduction is a technology which Honda developed for light-duty applications, but I noticed the Eaton Corporation offers this technology for heavy-duty trucks, or at least they're advertising that they offer it. So there's a lot of technology yet to be there, and the urea may not be the final answer. It may be an interim solution. We just don't know. Wait and see what happens. But it's very important because this sector is really coming to dominate NOx emissions in California. So, in conclusion, I can tell you if you enjoyed challenges and successes, the Air Resources Board is a great place to work. And I can say that after 10 months' experience. Thank you very much, and I'm quite open to all your questions. We're going to be getting questions off the web also, so I will read those if I like them. And please use the mic because of the webcast.
Can I make one observation? One thing I saw was even though you've had this great career, and you've stayed in research and up in all these different fields, you've also gotten time to get out of the office and get some activities. So maybe a lesson for all of us.
Yeah, absolutely. It's really important to do that. Work is wonderful and exciting, but there are other things, and I think so many people have other things that they really enjoy doing, and that really helps the work, I think, to get away from it once in a while.
Great. Question?
Dr. Sawyer, what can we do, or should we encourage auto manufacturers to bring in plug-in hybrids to the marketplace sooner? I live 10 miles from work and would just love to be able to come to work on battery power alone.
Well, I think most of us think that plug-in hybrids are a great idea, and how to make it happen, we're not too certain. We know that the electric companies, that PG&E especially, is really behind this technology for their own reasons. It's a good electric market for them. It helps balance their load. We're seeing a lot of sort of home conversions or small-scale conversions. The Davis Group has been the one who's really pushed this beautifully and demonstrated what can be done. But for this to take off in a big way, it has to be an OEM and one of the big manufacturers to do it. The obvious one are the ones that are leading in hybrids. We visited Toyota. They absolutely refuse to say what their plans are. We keep hearing rumors that they have these vehicles that are out on test already. I haven't seen one. It may be part of our ZEV review. There may be something that will come up in that which will encourage more rapid introduction of these vehicles. I think there need to be some large-scale tests, market testing of these. Because, I believe that there are a lot of people out there that would plug in these vehicles, but that's an issue, whether if they had a plug-in hybrid, whether they'd plug it in, sort of like an E85 vehicle, whether you ever put ethanol in it or not. And we need to understand that, and what market second. I think the industry needs to understand that. They're the ones who have to be convinced that there's a market there. They're going to be more expensive. It's the battery problem again, because they do need a bigger battery than an ordinary hybrid to make them work well. So anybody has ideas how to push this technology and get it into California, we'll certainly consider it, try to work on it.
I was wondering what your thoughts were on the role of biodiesel in our program. That's something I get asked about a lot from my friends and stuff.
Thanks to Willie Nelson and some people in Berkeley, biodiesel is very popular amongst the environmental movement. We are still trying to sort out what the fuel spec should be for biodiesel. We think that it makes a lot of sense, that we don't see any big problems at B2 or B5. Looks like the manufacturers are quite willing to accept that. Daimler-Benz in Europe fuels its vehicles initially with B2. So, in the long term, the problem is that it's unlikely that there'll be enough biodiesel available to really make a huge difference, to make much difference in the diesel market, a big difference. Big difference means 50% to me. That's not to say that 10% wouldn't be worthwhile. The military in California has a number of vehicles running on B20, and they seem to be having no problems, although there are warranty issues. Those need to be worked out first. And the people who are collecting deep fryer grease and processing it and the like, it's a good use of deep fryer grease, but that's not going to go very far. So there is no, I hate to say this because I said one thing I don't like are cliches, but there's no silver bullet in this area. It's going to take a combination of a whole lot of different things. And we're going to have a lot of choices and a lot of different contributions to solving the problem. And I don't see one clear winner. Dr. Denton?
Dr. Sawyer? What kind of future do you see for light-duty diesel? Are we going to be seeing light-duty diesel Mercedes like we used to? Or
oh, yeah.
That's here.
You're going to see them next year. We don't know exactly when, but they are set to bring a fleet in the thousands of vehicles into California for tests next year. They want to assure themselves that the U.S. market is ready for diesels now. And I think it's a no-brainer. I don't know if you've driven any of the European diesels. They are quiet and powerful, a lot of low-end torque. So they have a lot of response, and they get, roughly 30% better fuel economy. So it's another reason why they're going to happen. Sales in Europe it depends on the country, but they're in excess of 50% now are diesel from the light-duty sector. for different reasons. Their emission standards are not as stringent, and there are tax advantages in some countries. But no, we're going to see a lot more light-duty diesels. And, you know, there was a time when diesel meant dirty, and in California that just wasn't allowed. But if they meet our standards, they'll be here.
Dr. Sawyer, as the owner of a lawnmower, a leaf blower, and other off-road engines, I noticed those weren't on your challenges here, and that seems to be something that, you know, I heard Catherine mention the other day, a catalyst on every engine, and I just wondered if that was in our future.
Well, I'd like to go a step further than that. There's some wonderful devices like rakes, push lawnmowers, and, you know, people do not like the government interfering with their personal lifestyle. So far be it from me to tell you you can't have your leaf blower. But I hope the time comes when, you know, your kids go to you and say, "Dad, look at this neat thing that I got for Christmas. It has a handle with some things at the end of it, and it cleans up leaves without making any noise or consuming any fuel." And I guess I'm serious about that too. You know, I think that's where the solution comes for some of these things that we're having a hard time dealing with. Is the substitutes are probably better than the devices, but they can all be made clean as well. So I'm certainly in favor of doing that. It looks like we're winning the battle of the small engines, so that's good.
Dr. Sawyer mentioned that rails could be a good part of the solution for goods movement, but it could also be part of the solution for passenger movement as well. And I was recently in Japan and traveled the whole country without ever having to get in a car. And I wondered, what do you think we can do to impact the growth of rails, even though our ARB has no direct authority?
I'm a big rail fan also in the long term, in the really long term, because if you think about what's going to happen to California, California is about the size of Japan, about the same extent also. And although I hate to think of our population being 120 million, I think is what it is in Japan. You know, 100 years from now, that may be what we're facing. And even if it's only twice what it is now, having rail transportation would be awfully nice. And if we're going to do that, we ought to be investing in it now, getting the right of way, putting the major lines in at the present time. And I think the rail makes a lot of sense. I think that we're highly dependent for long distance travel on aircraft, and aircraft are a lot more efficient than they used to be, but they're still not very efficient when it comes to CO2 per passenger mile, and therefore I don't think we want to expand the growth in that area. And I think if we're going to take increased passenger miles, that we ought to really focus on public transit and the rail part of that. The goods movement, I think, will make more sense sooner, probably, because the pressure on how to move goods around is going to continue to grow. And rather than putting more trucks on the highways, putting more railroad cars on existing rails, and probably putting some new rail links in as well. It seems pretty obvious. Yes?
Thank you. Health costs. And that is, it seems, as our transportation vehicles, and I think it's pointed out in previous secretary's book, Tamanen's book, the cost of using an automobile, the cost of the pollution that's produced from it in terms of the health impact is basically being absorbed by society and not being absorbed by the producers of the motor vehicles. And I'm wondering if, in terms of like rail, buses, people generally don't take that kind of thing into account if they're trying to, argue for some sort of public transportation. It's sort of like, well, what's the time, what's the personal cost in purchasing the vehicle or purchasing the ticket for the train or the bus? But I think we have all this health costs, which just kind of sits out there, which is really not being taken into account. So I wonder if there's a way of starting to think about that or educate that so that it would make transportation in buses and rails more competitive or more acceptable in terms of that.
I don't think it's a very productive way to go, and I'll probably get quoted on that, and I'll be sorry I ever said that. For one thing, if you want to internalize these costs, you're not going to get the auto companies to pay for them out of their current profits. And I think with good justification that they're going to say, you got to be crazy to do that. But as far as public transit goes, it's highly subsidized at the present time, and I think it's highly appropriate that it be so. I don't think, there's not a public transit system in California that pays for itself at the fare box or anywhere near it. The Bay Area Rapid Transit is the one that has the highest fraction that comes from the fare box, and it's less than 50%, I think, something like that. So these things that are in the public good, you know, it's quite appropriate for them to come out of public funds to do that, and that's my own political philosophy. Health costs are huge, but the air pollution health costs of automobiles are not the major health cost of automobiles, which is the death and injury from automobile accidents. And if you really want to put public money into saving costs, what you want to do is to cut down on that sector by enforcement, safe driving enforcement, drunk driving enforcement, roads, making sure the roads are in good condition. And, you know, that's where I'd put my money if I want to put it. And also I think that individual responsibility has a lot to do with it too. And I really believe we need to promote that. It's hard to convince people if they walk rather than driving that their health costs will go down. But it's pretty obvious that they will for a variety of reasons. Less air pollution, better exercise. That's my social philosophy. That's not my science philosophy. But good point.
Hello, Chairman. I had a question on the... Hello, Chairman. I was curious to get your thoughts on the hydrogen highway. I know you touched on it a little bit in your presentation, but I was curious, the governor's really been pushing this hydrogen highway, and there are problems with the infrastructure, building up the filling stations to have it feasible for the average person to utilize hydrogen vehicles, and also the issues associated with the explosiveness of hydrogen. I just wanted to get your thoughts.
There are a lot of questions in there. Let me start with the explosiveness. I think that's a problem which is pretty well solved and can be solved. You have to pay attention to it. But gasoline is extremely dangerous also, and we've learned how to deal with that. And I think that can be handled with the hydrogen too. So I wouldn't put that high on my list. The big problem with fuel cell vehicles and the hydrogen infrastructure is where to get the hydrogen from. And until we get that sorted out, it's not going to be there in large volumes. That does not mean that this is not the right time to get started. You know, my guess is several decades away before there's a possibility of hydrogen becoming a major fraction of the motor fuel in California. And by that I mean 10%. Because that requires putting the infrastructure in, getting a fleet of vehicles out there, finding a source of hydrogen that makes environmental sense. I think it's a technology which has the possibility of taking over in the future, and therefore it's well worth investing money at this time. You know, if it's going to be, say, a 50-year time frame, or say it's 2050 before it really takes over and all the vehicles sold are fuel cell hydrogen vehicles. In order to make that happen, you have to start now. And so this is the right time to be doing it. to be getting the experience, getting some fueling stations out there where people can actually take their vehicles. The industry is putting vehicles in the hands of individuals now, and there are a few out there driving around, but they can't drive very much of anywhere because there's no place to refuel. And the range is low because hydrogen has low energy density. So it's going to take a long time for hydrogen to happen. But I think that the technology is good enough that it's worth showing that it can happen so that we have that option available in the future. And I think the timing is right now. The governor may have had in mind that by the end of his second term that Californians would be driving around in hydrogen vehicles. I think he knows that's not the case. It is going to be a much longer term technology than that. But I would certainly keep it available and invest in it.
I just wondered, we did get a webcast question here.
Oh,
so
good.
I thought I'd make a little intermission. So the question is, you stated that Smog Check needs to be made more honest, and wanted some of your thoughts on this. What do you think about going to a centralized testing versus the existing decentralized system to reduce fraud? Part two of the question is, will Cal beat USC in a couple of weeks?
Oh. Go Bears. The idea of a centralized smog check program, and I take that to mean one run by the state of California and disinterested in making money out of it. I don't think that's going to happen. There is a infrastructure of substantial investment out there running the smog check program. So I think what we have to do is to work with the system we have now and make it work better, and look to the future on how it should work. I don't think we understand very well how well it's working, which is one of the problems. We have a major study going on now, which is going to be reporting back, I don't know, next few months. An assessment. We're constantly assessing with the Bureau of Automotive Repairs how well it's working. We have people taking failed cars out to see if they're getting honest checks and the like. There's a lot of programs like that going on. And they tend to show that the program's not working as well as it should, and that the California citizens deserve to have programs that work better. So we should constantly strive to improve it. I think the next technology which may be there is how the onboard diagnostic interfaces with the smog check program. It is likely that onboard diagnostics will substitute for a tailpipe test. That the onboard diagnostics would be performed at the smog check station, but instead of putting something in the tailpipe, they would tap the onboard computer and get the information off the vehicle itself. That's a pretty substantial change, and how to put that in place will be touchy because, you know, who gets the money for doing it is always a big issue in this industry. Oregon, I believe, is putting in place a system where you can do it by yourself. That is, you go to your local gasoline station, pull up to the onboard diagnostic check system, plug your vehicle in, it reads it, gives you the information, sends it off to the state of Oregon. Wow. And, you know, I hope that they have a good experimental program on evaluating that and how it happens, because we're going to watch that very carefully. And, you know, if it makes sense, that as a motorist, I think that'd be great. So there's a lot going on in smog check, and you know, there's no answer. We don't know. It's, you know, there are a lot of interested parties in this, and I really appreciate the cooperativeness of the citizens of California and how they've gone along with it, and because it is invasive, and people don't like to do it. But I think it's a very reasonable program now. I think the 6-month or the 6-year delay in your first check makes a lot of sense. Otherwise, you just measure a lot of clean cars, which doesn't do any good. We would like to have an annual check for cars that are dirty rather than every 2 years. Maybe simply by age. When they get older, they have to be checked every year. That I suspect would be very unpopular. And we don't have the say on what happens. It has to be action of the legislature. I would like high-use vehicles to get checks regularly, brand new ones. There are vehicles out there, delivery trucks that are driven into the ground over a few years. Taxi cabs are a sector which are notoriously bad. We ought to target the dirty vehicles. We're getting a lot of proposals for remote diagnostics or remote testing, remote sensing as a way of picking up dirty vehicles. We constantly look at that. We just haven't seen a system that we're convinced really works well.
Dr. Sawyer, you have spent a large part of your life as a scientist, and yet you are also familiar with policy-making process at ARP here. Given these two backgrounds, how would you change the dynamic of policy-making process at ARP here within the constraints of scientific evidence that usually involve a lot of uncertainty? On the lighter side, a lot of us also wondering whether you're commuting to work here from Berkeley?
The last one's easier. I have an apartment 9 blocks from here, and I walk through Capitol Park every morning. It's wonderful. I commute to Berkeley on weekends or sometimes to our place at Lake Tahoe, so I sort of commute, but only once a week. And it's lovely. I love Sacramento. Great. I heard how terrible the weather was here, and the weather here is wonderful. Great. Maybe climate change has done good things for your winters or something. But science and policy, good science and good policy, and how could we do it better? I think the Air Resources Board does a good job. You have always put a high priority on your technical staff. They tend to dominate in numbers, which I think is good, but there are a lot of good people with backgrounds in political science and people who are and law and people who are astute at dealing with the political issues. And I think you listen to each other and help each other do your jobs. I would not pretend to design an agency, I think, that works any better than the California Air Resources Board in bringing good science to bear on good policy. I think you are a model for other agencies in the state of California. And for other regulatory agencies internationally. And when I lived in London for 2 years, which I did just before I'd pick up the paper and there'd be articles on the front page of the London Times once a week about what was going on in California. They're fascinated with California. And about half of those would have to do with what the Air Resources Board is doing. Wow, you're known internationally, so you must be doing something right. And I would not suggest changing anything. What we must do is hire and keep good people. And we're going to be hiring people. It's very important when we bring them in that, that we train them well and that they know what a great place this is to work. But it's a wonderful opportunity for all of us. Enjoy it. Keep doing the good work.
Yeah, Sasan. Thanks for the travelogue. I always enjoy good pictures of the Sierras.
You're welcome. Watch out, I'll bring my complete slide selection.
Excuse me. I've been trying to catch up on what's happening in the world of HCCI, and I'm not familiar with the engines you mentioned that are in production. Can you enlighten me?
Well, since I am a mechanical engineer and this is my field, say just a little bit about it.
Me too.
The HCCI concept, for those of you who are not mechanical engineers, is to pre-mix the fuel in the air in the diesel engine before it ignites. The idea being, if you can do that, and diesel engines burn lean so that when it burns at a low temperature, gets no NOx. The temperature is too low for the NOx to form. And there's so much oxygen around all the fuel molecules that no particulate forms. Now the problem with this is that when you get ready to ignite it, it tends to all go off at once, and it's very noisy and very hard to control, and you have no control over when it goes off. It's like a spark ignition engine, but with a spark ignition engine you can control when the combustion starts. In the HCCI, you have no way of controlling it. So the trick is to get the mixing to occur right and to have enough carryover of old gases so that the ignition is promoted by the previous cycle. And you do that through internal exhaust gas recirculation is probably how you do it. And you need a lot of control on the engine. You need, variable valve control. The fuel injection has to be multiple. But with the computer and valve control now there, all of the technology is really positioned to make this happen. I picked up on this about 5 years ago in Japan when it was demonstrated to me, and I said, yeah, it's really nice, it's a laboratory engine. Have you tried this on any production engines? Oh yeah, come into the next lab. And I went in the next lab, and there they had a production engine, and they were running it, and they would put it in one mode and the other mode, and the emissions would disappear in front of your eyes. Oh, well, this is sort of magic. And I said, how long do you expect before you're in production in this? I said, oh, we went into production last year. And this was Nissan, and they had a van operating 5 or 6 years ago, which operated HCCI. Well, the thing is, it operated HCCI about 25% of the time, and the rest of the time they put it into ordinary diesel mode. But that envelope over which it operates, every time I go to a company, the envelope's getting bigger and bigger and bigger. And it used to be they said, oh, it'll never happen, we can't operate over the entire load. Now they're saying, well, we're working on it. That's what I hear. So. And I think this is true of the heavy-duty engines that are being produced or will be produced in 2007, that many of those will operate partially in HCCI mode. Once you put all these different controllable variables in the engine and a lot of computer smarts, the technology may work and happen. So it's. And the industry likes it, of course, because it would be a cheaper way to meet the emission standards.
Hi, Dr. Sawyer. I was wondering what you think of a carbon tax, or even better, greenhouse gas emissions tax for moving us towards a low-carbon economy?
I won't answer that directly, of course. I think we need to send signals to people about the value of carbon, and the high price of gasoline is a pretty good signal. It would probably be better for the economy if the money went somewhere else than where it's going, and I'll just leave it at that.
Turn it on. It's not on.
I'm on the subject of waste, municipal solid waste, all sorts of wastes that this humongous population in California generates. And it's not our agency, of course, that focuses on waste conversion, perhaps thermal conversion processes, unless, of course, it impacts air quality. And then I know that's handled on the local level, but I'm just wondering if ARB has a position on using, waste conversion to energy, whether it's a hydrogen as an energy carrier or directly to electricity as a solution to air quality problems, because a lot of waste is trucked far away. And also decomposition in landfills is an air quality issue as well. And I'm just wondering, I know it's a awful place to even think about going, because the political implications of it are mostly political, but I'm just wondering, as a sound scientific judgment, if the board has a position on this.
I don't know whether the board has a position on it or not, but I'm willing to put my own neck out there and say that, of course, it's a wonderful idea, and it will happen. There are two things going on in California that really will make it happen. One is that the Integrated Waste Management Board, as you may realize, just passed the 50% mark on recycling. And a part of most recycling programs is to separate out the organic waste. And that stuff now is being, I don't know where it goes, it's mulched or something and used for soil conditioning, or hopefully not being buried. But it's fuel. As a combustion person, the worst, you could at least burn it. But, and some plant waste is burned for power generation in California, and more of that makes a lot of sense. But turning it into fuels, I think, is is going to happen. And whether it's bio to liquid or bio to gas fuel, those technologies are all poised to happen. And we need to do that as a matter of policy to make that happen. Because, you know, every gallon of fuel that comes from that source is going to be a gallon that's not coming from petroleum or worse, tar sands or coal or some other high CO2 source. So I can't say it's board policy, but I bet if you ask the board that nobody would disagree with it.
Not on. Would you mind standing up?
Is it? Okay, it's on. One of the questions that was, I don't think it was followed up very nicely, but it's something that strikes who takes a train ride from Sacramento to Los Angeles is that they get to, instead of riding on a train all the way, they get to ride on a bus twice as part of that supposed train ride. Also, anyone who's in California ever visited a port, I know we're trying to make significant progress on goods movement, is struck by the fact that our ports are nearly 100% congested. Whether that's Oakland or San Pedro or Long Beach, you can kind of pretty much see that what's really needed is significant infrastructure expenditure in building significantly additional rail links. And from a perspective of a person who lived in Los Angeles for 19 years, when I was there, there were very few rail links. There were no rail links. The red line, blue line didn't exist. But as soon as they were constructed and put in place, they were subscribed almost fully. There's in fact a picture somewhere, an LA Times picture that showed Highway 10 and as well as the line that runs, the Metro link that runs, all of them being, you know, fully subscribed. And I'm wondering, is there any way from the AB 32 authority that we're being given to sort of encourage these kinds of infrastructure development?
Well, I want to say yes, but you'll probably ask me how, and I'm not quite certain what the answer to the next question is. I think AB 32 gives us the authority to reduce greenhouse gases. And if we can demonstrate that by moving goods off of trucks onto rail, that we can do that, we should be able to figure out a way to make that happen. We're going to have to use promote a lot of different things. Some of these areas, such as that one, I think the economics will help drive it, which is always very important. And those are presumably the easier things to do. The ones that pay off are a better choice. I know the rail industry is very interested in expanding to handle more goods. I really didn't answer your question, but we will certainly keep that in mind as something which would make a lot of sense.
Thank you, Mr. Chairman. The first thing I'd like to say is thank you for the long-range vision that you have. I think that's something that we truly need beyond what we're looking at. And my question is going to address that. We're really good at the regulatory controls to get to some of these shorter range goals. What non-regulatory tools do you see the board maybe taking a more active role in to get to some of these more long-term policy, how we see the world shaping in 100 years kind of goals?
Well, just watch, because we're committed to enter the world of markets and to promote markets to make the right things happen. And this is not an area in which we have experience or expertise, but I can assure you we're going to draw upon the best thinking we can from around the world. And there's a lot of experience elsewhere. You're going to begin to see teams of people coming in from Europe and from Japan to brief us on market strategies and how they work. So it's going to be a whole new realm for the Air Resources Board, but we're committed to doing it right and doing it well. So you'll maybe see seen more economists than you're accustomed to.
Dr. Sawyer, I think it's appropriate that you were just mentioning markets, because I think the market strategy that we're embarking upon per AB 32 makes incumbent on us getting a good market model. And I think recent experience in Europe shows that emission allocation and cap definition are the key to that. And I'm quite concerned that we are unprepared to properly manage an emission inventory for greenhouse gases and to validate that inventory by ambient measurements. And so do you have any thoughts on how we might move into being able to properly audit and therefore properly manage a market-based system?
As you probably know, I really believe that getting the inventory right is extremely important, not only in greenhouse gases, but also in the emissions that we regulate. And I heard an echo of a question, which I heard the day before yesterday, about how do we really verify the emissions. And I think this needs to be done at least twice. One is at the source, to make certain that we really audit the emissions and understand how they were calculated and whether the numbers are right or not, and whether what we're told is going on is what's going on. We will probably involve perhaps the local air quality management districts in helping with this task on individual sources. But I also think it's important to have a way of checking. And I like the idea of ambient measurements as a way of checking. It's pretty obvious that you can use those for some of the greenhouse gases, whether you can use them in some useful way for CO2 or not. I'm not so certain on that, but there may be possibilities. Measuring fossil carbon and new carbon and such things as that, and trying to make sense out of it to see whether the numbers are consistent. So we're going to have both top-down and bottom-up based inventories. And we have always worked from the bottom-up inventory side of things, so I think we're really good at that. The Energy Commission has tended to do it the other way. So, my preference is to keep those separate to ensure that they come up with the same answer, and when they don't, that tells you what you have to figure out what went wrong. So if you have proposals on how to measure things in the atmosphere that will tell us whether we're getting the inventory right, please put those out there. I heard that question before, and I agree with you. I think for the refrigerating gases, that there may be some really useful things that could be done there.
Well, we plan for 2 more questions, and then go ahead, Albert.
One of the issues that you listed, one of the 4 is particles, and with respect to mobile sources and particles, Europe is moving forward, and they're certainly making headway much beyond what we've seen here in the U.S. and in California in the issue of particles and mobile sources, light-duty vehicles, heavy-duty vehicles next. If you fast forward, what is your direction after 10 months on the job in terms of where you would like to see the agency go beyond left to 2010 standards for vehicles, engines, and this issue of particles?
The Europeans sound like they're going to issue a particle number standard, particle numbers per kilometer for motor vehicles. We've discussed this internally a lot, and also with the OEHA people, and we don't see the health-based science to justify that at the present time, but we certainly need to keep on top of it. We need to have good characterization of what the particulate emissions are and what the exposures are, because as you know, the fall off in ultrafine particles is very rapid. We need to understand that very well, what people are exposed to. And we should be prepared to move in that direction when the evidence is there. But I think the sound science has to come first. At the same time, we should not require or allow the introduction of technology which increases particle numbers as the particle mass comes down.
Last question?
One of your slides mentioned E10 versus E85. I was just curious if you have any personal thoughts on that, and if you think it should be more of a marketplace solution versus a command and control.
If it turns out that ethanol is really a good greenhouse gas reducing fuel for motor vehicles, that is, we have a good source of ethanol which is low carbon, which doesn't happen at the present time. And the second thing is that it's going to have to be economical, or it's going to have to be priced in a way that people will buy it, because it's not going to work if you have expensive E85 out there and people don't buy it. The way to get a lot of ethanol in fast is to blend it in all gasoline to as high as you can without hurting other emissions. And I think that may be E10. I don't think we're quite ready to say that yet. But if you want to put more ethanol in, then it seems to me that it has to be into the flex fuel vehicles, into E85 vehicles. And we're considering a lot of things which might drive in that direction. I think one thing that I can mention is a carbon cap on fuels. And I think you can sort of think through how that might drive more renewable fuels into the marketplace. A lot's going to be happening, I think, fairly soon. If we lose the Pavley lawsuit, we will act rapidly on the AB 32 authority to come up with something to give the same reduction in a different way. So stay tuned. There's going to be a lot happening. And we want to think it through very carefully, and we want to do something that makes sense, and we want, Catherine and I both like tons, and it must be in the most cost-effective way. So that's why I say a blend of the two. If you need to go beyond E10, then it's probably a mixture, not E50, but E85 and E10.
Great. And I think we'll end it with our last question from the webcast is, will there be an increased focus on outreach, especially education, for the next generation of consumers?
Absolutely. That's a high priority on my part, and I think I've stated that several times. It's not happening as fast as I'd like to, but I hope we can get the resources to make that happen. I think that every one of you has an educational role to play, whether it's with your neighborhoods or your school, local school, church. That's just the beginning. We need a much more organized outreach program to explain to the public what the problem is, what we're doing about it, what they can do about it. Because a big part of especially the global warming solutions has to be modification of behavior. And it's a very touchy business. And to me, that means education. I don't find that a threatening thing at all. That's what education is all about. It's informing people so that they can make good decisions on their own. So I think you'll see more of that, more resources going into that. Turn the lights off when you leave the room.
Not yet. Good. Thank you very much, Dr. Sawyer.
Thank you.